next types of conic sections that we will discuss are ellipses and parabolas. So let's start with an ellipse. So imagine that I have 2 points in the plane, the red F's here, this F prime, this F. So those 2 points, if I were to tie a piece of string to them and then pull the string so that it's tight up here to this point P, and then move it all the way around like in a circular fashion, the figure that would result there is an ellipse. So it's all points that are the same distance from the sum of these 2 points. That's what that string would represent. All right, so these 2 points are called the foci. This is one focus and this is the other focus. Along here we have the major axis. That's where the ellipse is elongated along. And then the shorter side of the ellipse is our minor axis. So the B's represents the endpoints of the minor axis, the A's the endpoints of the major axis, and then the C's are the coordinates of the focus that are there. So our equation of the ellipse, how do we get to it? Well, let's discuss this briefly. Remember that I said that the distance, it's like tying a piece of string to these 2 points and pulling it tightly, that the sum of that distance remains a constant. Well, imagine that I pulled the string, this point P, over here to A. Then I'd have this distance here, which is symmetrically the same as that distance there, right? And this distance here, which is all this distance out to A plus that little bit of C. So notice that since I would add this distance back to that point there, I would end up with this distance being twice the distance of A geometrically. So it's equal to 2A. Now this distance here is our distance formula from college algebra. X minus the x coordinate would be x minus c squared. And then the difference of the y coordinates would be y minus 0 squared. And we square root it to get the distance formula. And then this distance would be the same thing. The difference of the x coordinates and the difference of the y coordinates, so that's y minus 0 again, squared. And then we would square root the whole thing to get the distance formula. So the sum of those two distances is this distance plus this distance, and it has to equal 2a. Then, to get the formula for the ellipse, oh my gosh, we do a whole bunch of math here. Now, you can pause the video and follow this through if you want, but basically what we're going to do is we're going to isolate this square root first by moving this to the other side, then squaring both sides. Remember, we have to FOIL when we square this side here, right? Square that and it FOILs. Square that and it just undoes the square root. And then I need to isolate this square root again. So all of this is getting this square root by itself so that I can once again square both sides here and here. Again, I have to FOIL this side when I square it. And then it's a bunch of rearranging so that we get the x squared and the y squared in the numerator by themselves, and it equal to a 1. So when I do that, I end up with x squared over a squared plus y squared over this quantity squared. We're going to rename all of this a b. So this is b squared equals 1. So I can put it into that form. X squared over a squared plus y squared over b squared equals 1. That one was elongated along the x-axis. If I elongate along the y, it switches. But you don't actually need to remember that. The main thing here is it's elongated under which the number under the variable shows which axis that it's elongated on. So whichever has the bigger number. Okay, so if I've got an ellipse with a center at the origin, we would have x minus 0 and y minus 0 squared up here in the top. So it's just x squared and y squared in the top. And then it's elongated under whichever is the bigger number, this number under the x or this number under the y. That provides the endpoints of the major axis, and then the endpoints of the minor axis or the other one. Then I can find the foci using this formula, the bigger number squared minus the smaller number squared from here. Okay. And then it's just, if it's flipped along the major axis, but we're not going to use these formulas because we're just going to remember that bigger, smaller thing that I said. Okay, So I want to graph this guy. Now, all of these equations had a 1 where the 36 is. So the first thing that I do is I divide everything through by 36. So if I divide everything through by 36, I get x squared over 4 divided by 36 leaves a 9 in the bottom. 9 over 36 leaves a 4 in the bottom. And then 36 over 36 is a 1. So we're bigger under the x, so we're elongated along the x-axis. So the x-intercepts are at the square root of what's here, so plus and minus 3. The y-intercepts, the square root of what's here, so plus and minus 2. So my center is at 0, 0. I'm going to plot those points, and I also need to find the foci. So I do the c squared equals the bigger number squared, so 9 minus the smaller number, 4. 9 minus 4 is 5. Square root it, so c is a plus or minus square root of 5. So now I can plot the center at 0, 0, go up and down 3 from the center, left and right 2 to get the, sorry, I went the wrong way. Sorry, up and down 2, left and right 3, and then the square root of 5 is my distance here. So square root of 5 is a little bit more than 2, because 2 would be square root of 4. Okay, so my graph looks something like this. Notice the domain goes from -3 to +3, and the range from -2 to +2. The x's and the y's. All right. So to graph it with my calculator, I first have to take this equation and solve for y. So here are my math steps to do that. Notice that when I get the y squared by itself, I then have to square root both sides and I get a plus or a minus. I'm going to have to put in 2 separate equations, a plus and a minus, to generate the full graph of the ellipse. All right, let's do it again with this equation. First thing I want to do, divide by 64, so I get a 1 on the right-hand side. So I'll have y squared over 64, x squared over 64 divided by 4 is a 16. Now, the bigger number's under the y, so I'm elongated along the y-axis. So my major intercepts are at 0 and plus or minus 8 for the y, and then square root what's here for the x-intercepts, because that's the minor axis. Now let's find the c. We're going to go 64 minus 16. 64 minus 16 gives me the 48. Square root it, and we get 4 root 3. Of course, that's a little less than 7, because square root of 49 is 7. So I'm going to plot those, plot the 8 and the -8, then 4 and the -4, and then draw my ellipse through those points. And it looks like so. Notice my domain is -4 to 4, and my range is -8 to 8. All right, now let's find the equation of an ellipse having the center at the origin and a focus at plus or minus 3 and a major axis of 8 units. Well, if the center is the origin, we know that x squared plus y squared are going to be in the top, the numerator of each of those fractions. So my length is 8 units, so we say 2a is equal to 8, so 80a would be 4, divide both sides by 2. And now we can find the c by plugging this 4 in for the a, minus the b squared equals that c squared. Well, we know that the foci is at 3, so 3 squared. Go ahead and solve. This is 16 minus 9, so we get a 7, and then divide off the negative, so it's b squared equals 7. So the 7 goes where the b squared is, and then we get the 16 from that 4 squared, the a value, and then plot it, right? So we're going from the center of 0, 0, up 4, down 4, and then left and right, square root of 7. Now notice that the focus is along here. That's that 16 minus 7, which is 9, square root, so at 3 and -3. Now our domain is -√7 to +√7, and the range is -4 to 4. All right, so if I center my ellipse at a different point other than the origin, say at the point HK, then remember our shifts, x minus h and y minus k shift me to that new center. So I'm replacing that inside the squaring function. Now, everything else stays the same. The bigger number shows whichever variable it's under, that shows us which axis we're elongated along. And the C formula stays the same, except we're moving that distance C, A, or B away from this HK point instead of from 0, 0. Let's take a look at one. So my center is at +2, -1, and the bigger number's under the Y. So from -1, I'm going to move up and down 4. So 2, -1 is where my center is. So moving -1 by 4 takes me to a 5 and a 3. Now, we're moving along the x by 3, the square root of the 9. So I'm going to move left and right from this 2, 1 by 3 units. So we're going to go to -1 and +5. -1, +5, and then here's that up and down by 4. Now, how do I find the C? 16 minus 9 is a 7. So from here, I'm going up and down by square root of 7, a little bit more than 3. All right, guys, that's our ellipse. We're going to pick up, I'm sorry, one more. Let's look at graphing it on our calculator. So I would have to solve for y. So we go through that same process again, solving for y, and then we can graph the two equations on our calculator. All right, we're going to pick up on with the parabola on the next video.